Yeah, so now I'm going to make a real simple function block. This function block is also going to have a square wave output, but with a variable frequency. And then we have to make an instance data block. That's the data area where the function block is storing its data. And then we have to call the function block to make it execute its program. Yeah, this is the project template, a template project again. We are just going to go down into the program section. And here it is something is prepared, not tasks, but in main program sections and simple POU. Here's the square wave function in here. So now I am going to make a function block, and here I have to write some code. So it's going to be a little more programming, but not much more. What I'm going to do is I'm going to down here in system, there is an instance data block. So it's just a data block. This one is now protected. And here is a long timer that's running in this instance data block. I'm going to use this timing system for my timing in my function block. And under my library here, there are some system function. This one is going to get a long time tick. What it does, it's just collecting the data out of this data block here. So I'm going to use this function for my timing. Okay, I can collapse this again and start to make my function block. Add new block. And that's a function block. And I prefix that with fb square. I have the W in there. Yeah, we can call it that. It's this variable frequency. The other one is a fixed frequency, but doesn't matter. So here's the code section, and here now I'm going to write some variables on it. ppd parameter post duration. It's going to be long time. Long time is a special time format. It's going to be retain, and retain is that if I switch the power off my PLC and restart, that the value in ppd is going to be kept. So this is pulse duration. And the long time is basically a time that is the number of nanoseconds since the January 1st, 1990, I think, for this PLC. I have to do a little more for my timing system, and I know what I am going to do, so I'm just going to write my variables right away. I have an output Boolean. Variable. It's not that important what we write. I don't have any input output, but I have a static s time. That's going to be long time. I'm not going to show this on any HMI screen, so let's remove this. Timer store. And then temperature TLT now. Like this. Also long time. And time. Now. And I'm also going to use one for calculation. So okay, I'm just make some lines in here. Popular temporaries, I think it was written correctly. So I just prepared the temporaries I'm going to use, and I'm going to use this TLT now. I'm going to set that equal to the function getLongTimeTck, like that. And here I can write get the current time tick. This is going to count all the time, count up. So what do we have to do now? We have to do some calculate the time diff since last output. I'm going to toggle output TLT time use a space now but time. That's IntelliSense. I should probably put in the minus too. So I wrote the comment over here, so I don't have to write anything after him, because after the line. So see // that's line comments. Okay, now I have the time. I don't know what is in the long time, the store here now, but I'm going to update it later. So what I'm going to do now is I'm going to check if this time is greater than my parameter here. And that's an if sentence. If parenthesis TLT time f1 greater or equal to ppd tabulator, then the line is completed. Then what I have to do is I have to restart my timing system. So SLT time I'll write comment and then I have to toggle my output, and I could do that directly, but what I'm going to do here is I'm going to use an internal hidden Boolean. It's not actually hidden. Oh, bool. Let's say image. This is supposed to be a protected area that can't be accessed by other parts of your program. In TI Portal and Semantic, that's not the case. You can access this from other parts of your program, but don't do it. That's forbidden. But I'm going to invert this one, because it's going to be true, false, true, false. So SB static Boolean Y equals not Y, like that. And a comment toggle and then just complete this and if. So that was the if sentence. And here write to output, but I have only one output, Y equals SB Y, like that. And here maybe a comment check if I said time has elapsed and toggle the output, which create a square wave, something like that. The comments are not that important. Save and compile. SquarePous. Okay, so now I have to test this. This is a function block, and this declarations up there, that's just a declaration part. There's no memory hidden behind there. So this function block needs some memory to store these variables here. And that's an instance data block. So I'm going to make one here. Right click, add new block. And an instance data block is just a data block. Same as use, but we'll call it IDB. What was called SquareWave. Global DB, that's a user DB, but if I select or use combo box, I should be able to find my function block SquareWave down here. So my data type here is my function block. So now I have made the data area for the function block, but still it's not working. So now I have to call my function block. And this was prepared for the program SimplePous. I'm going to call it here. But also here I have an output pulse. Or I'm going to toggle an output. So I have to do that here too. Let's say I have to go down to my PLC tags. I'm going to toggle an output. What I'm going to do, I can just write QB output Boolean. I'll just tabulator in there. It's a mess. I deleted it. QB. Variable SquareWave. I'm a tabulator to select the next free address. Here is. Let's see if I can expand this one. Oh, I'm too quick. Visible in HMI engineering here, but I'm not. And yeah, you're not the best editor of this stuff here. And if it's accessible from your HMI, but we're not going to show this on HMI, anything like that. So yeah, no, those line up. Yeah, here I can make a copy, Control C, Control V, double click on the fixed. So don't write more than I have to. Save. Okay. So now I can go back to my program SimplePous. There was no comments here, but I got to write a comment here too. So I can't write FB, or I could write fbSquareWave here, but then he would ask me for an instance data block. So that's not how we call it. What you do call is the data area, instance data, IDB square. It's down here, tab. And what you could do too, I could write, or what I could do, I could just drag it in. How's it? Okay. And it has an input and an output. I'm not going to set this one. I'm just going to set the output because I want to change this one in my instance data block when I do test it. But what it can do is that I can set the output. This is what they are. Now they disappeared, of course. But I remember the Y. That was Y. And some tabulators. And that was the QB. Like that. And then it changed an error. You say, okay, this is the Y is transferred this way, not the other way. In earlier versions here, there was a colon equal, and then it was not that easy to distinguish if this was an input to the function block or an output from. the function block. So it's changed to an error. Okay. Yeah, just have some comments. Maybe we should compile this. No. So I'm going to compile the entire CPU. See if I have some errors, but I don't. It's great. And now I have to test this. So it was a little prepared here because this program SimplePous that I'm writing in is already called here, and program main is called in the task background here. So that's a little cheating here. So it's been prepared, pre-programmed. So now I have to test it, and again I need a CPU. I don't have one, but I have my emulator simulator up here. Just make sure that this CPU, I just pointed the CPU, is this one. Activate that one again. If you're doing this, I can't work on real CPUs. The CPU is started. Okay, so now I get this when I started the CPU. He didn't remember from the last time. I've used this before, but he has forgotten it. So what I have to do now is that I select, okay, this is the protocol I'm using. This is the interface. It has two. It doesn't matter which one. But what you have to do is to type start search. See if he finds it. As it's the simulator, he answers to any call and says, I'm here. You found me. When I've done that, I select this one, and then I can load. Consistent download, yes, load. It's done. Now I can say finished. I could have started my CPU, but I can start it here too. If the CPU is 100, is way out somewhere where you are not sitting, of course you start it from TI ported. But now I could, I have my PLC on my desktop, so I can start it here. Okay, that's an error from an earlier error, but I can clear those, so now I don't have any errors here. So to test this, of course, what I can do here, if I'm lucky, I can look for, or I always look out for the glasses and the green arrow, and you can see, activate test here. This one is not flashing. So what did I do wrong there? So I just have to open my instance data block and look for glasses. Oh, well, it is flashing, but the time that's flashing is 0 seconds. So it's being timed out. So this is random numbers flashing extremely fast. So I have to write something here. Double click. We can start with a second, 1 second. So now it's flashing a little more orderly. You can see this one is counting too, because if I look at my function block, every second, I said this one is a second. So this is counting all the way, all the time. So it's counting nanoseconds since 1990. And I take the difference here between something I stored, and when that one is greater than 1 second, it inverts the output and updates this variable here. So then it's going to start for 1 more second, 1 more second, 1 more second. So when I'm looking at the instance data block, this one is roughly updated every second. Here. And every second it's inverting the output, which then creates a nice square wave output. So here, it would probably be better to say I have a default here. LT hashtag 6 milliseconds. That was the fast flash. At least I have something to start with, not 0. But then it says, okay, there's a change here and a change here. Let's see what happens if I can do a compile here. It won't let me compile this one. See if where did I do the change here. Compile this one. See if I can compile this one. Okay. I probably would have to go offline here to compile my entire CPU. I could change my function block and load it, but not my entire CPU. I can go back online. Like up here. Still, I haven't loaded anything to my CPU, so I would have to download to my CPU. It doesn't offer that. Here. Said okay, I want to download this one. Consistent download, load. Okay, it's all green. I go back to my instance data block, and then you can see the start value has been updated. So for new instances, it kept to 1 second that I wrote early on, but for new instances I make, this is going to be the default value. 6 to 5 milliseconds. So it's flashing a little faster. So if I go into my, I'm probably not going to be synchronous this. I changed that one to 1 second still. So this one is flashing faster than this one. So this could be an output to an LED or a lamp or something that's going to flash out in my process to notify a programming error or something, whatever I'm doing. Yes. So this was a function block, really fast. So what I did with the function block, I made a function block that had a flashing output. So what I did was I just inverted an internal variable, and I could do that in Boolean algebra. I just set in variable to the inverse of itself. As it's Boolean, that's true, false, true, false, true, false. And then I had a timer. I used a timing system that is in the template project, a LongTimeTck, and I just did a little calculation on that one. And by a pretty small program, I made a variable frequency square wave. If I used 2 parameters, I could have made an off-duty square wave. Let's say I had a difference on time compared to off time. So I could change the duty cycle on my square wave just by having 2 input parameters to do that. So I could have modified a little, but this one just created a simple square wave, and that was the assignment for this one.